Chapter 5, Systems of Linear Equations and Inequalities, for Section 5.1, Solving Systems of Linear Equations by Graphing. When we're talking about a system of linear equations, two things we want to understand about that. What do we mean by system, and what do we mean by linear? Linear equations is the topic that was at the end of Math 60. And they are equations that make a line when you graph them, which means that it has a slope, and it also has x and y intercepts. Again, these are all Math 60 topics. So if you need some refresher on that, please get some extra help as soon as possible. You do not want to have holes in your information as you get started with this class. So that's what it means by to have linear equations, but to have a system, what does that mean? That means that we have two equations or lines that are working together, or being looked at together. Another way to think of that is they're on the same graph. And part of what we're going to do with systems is to find the solution to a system of equations. And so what do we mean by solution? Well, it means a couple different things. First of all, a solution is the point having coordinates x, y, where the two lines intersect, or they cross each other. So if you have two lines that are graphed on the same graph, where they intersect, that point is the solution. It's a point on both lines. It's where the two lines intersect. There are a couple other situations that could happen. You could end up with parallel lines that don't intersect, which means there would be no solution. There is no point where the two lines intersect, which means there would be no solution to the system. The other option could be that the two lines are actually just two different representations of the same line. So if they're the same line graphed on top of each other, then this, in terms of solutions to the system, what works in both equations is there's an infinite number of solutions, which means it's all the points on the line. And we'll look at that option in just a little bit, what will happen mathematically if we have a no solution or an infinite number of solutions. But let's look again at what it means to be a solution to a system. It's the point x, y, where the two lines intersect. In terms of the algebra, the solution is the point x, y, that makes both equations true, or works in both equations. So our first set of examples have these instructions. Determine whether the given ordered pair is a solution to the system. So the key words here are the ordered pair, so we're looking for an x, y, and we're seeing if it's a solution to the system. It means it has to work in both equations. It has to make both equations true. So what that means is we're going to substitute the point x, y into both equations. So this is how we determine. We're going to substitute x and y into both equations. And it has to work in both for us to say, yes, it's a solution to the system. First example, page 298, number 4, 7 over 25, negative 1 over 25, that is our x and y. X is 7 over 25, y is going to be negative 1 over 25. And I look at my first equation, 4x plus 3y equals 1. to go ahead and rewrite it, but leave myself some space to put in my x and y to test it. So 4 times our x is 7 over 25, plus 3 times our y, which is negative 1 over 25. I'm just putting these in here. I'm going to go ahead and put a question mark over the equal sign to remind myself I'm checking to see if this works. And fractions here. By the way, if you have any issue with fractions, that is a Math 20 concept that you should be solid in at this point. If not, please get yourself some extra help and I can refer you to that. Check with me during class. 4 times 7 is 28 over 25, plus 3 times negative 1 is negative 3 over 25. Again, we're just trying to see, does that equal to 1? And 28 plus a negative 3 is going to be 25 for 25. That does equal 1, so yes, it works in the first equation. So it works in the first equation. Then we look at the second equation. And it is 3 times x minus 4 times y equal to 1. And again, I leave some space here. And I'm going to take my x value and put it in 7 over 25, y value, put it in negative 1 over 25, and I'm just going to remind myself that I'm testing to see if this creates a true statement. In this case, 3 times 7, 21 over 25, negative 4 times negative 1, plus 4 over 25. Here's another example of a Math 20 topic, positive and negative numbers, adding, subtracting, multiplying, dividing, all that. If you have any issues, any holes in your knowledge, anything you're just a little shaky on, again, you want to be solid as you move through mathematics, otherwise it creates a very shaky foundation to build on. So let me know if you need some extra help. We'll get you referred to the right resource for that. 21 over 25 plus 4 over 25, does that equal 1? 21 plus 4 is 25 over 25. It does equal 1, so it works in the second equation, yes. And because it works in the first equation, works in the second equation, then I can say, yes, 7 over 25, negative 1 over 25 is a solution to the system.